Hi, and welcome to question 5 of the 2024 paper 1 for the Leaving Cert Ordinary Level Maths. So question 5 is a tricky enough one here, and we start off again with algebra like question 4. Part A says find the value of the following expression when x is equal to 2. Give your answer in the form a over b, where a, b are elements of n. Okay, so it just says give your answer as a fraction, a over b. And both a and b are natural numbers, so they're positive whole numbers. Okay. Now, I think actually in the notes I've mistaken this question. Um, this is actually much easier than I thought it was going to be. But it says find the value of the following expression when x is equal to 2. So we're given an expression. It's not an equation. There's no equal. But we're told that x is equal to 2. Okay. So if you realize that x and 2 are the same thing, I can just do it properly. Swap out 2 for x everywhere. Now I'm going to do it in brackets, even though I don't really need the brackets there. Now you can put that in the calculator, or I can do it by hand. 3 by 2 is 6 plus 5 over 10. Take away, now 1 over 2 plus 3 is 5. That's the same thing as 11 over 10. Take away 1 over 5. Now if we're looking for a common denominator, it's 11 over 10. Take away 2 over 10. 1/5 is the same thing as 2/10. That's the same thing as 9/10. That's the answer. So again, at this stage here, I could have gone calculator and gone straight to my answer, 9 over 10. Yeah, okay. Now in the notes, I did the complete answers. I actually went and algebraically added them together, which is a whole waste of time, all because I didn't bloody read the question properly, which is an absolute flaw of mine. So B here says the function f is defined as f of x is equal to 5x squared minus 20x plus 2. And this is excellent. X is an element of R, which means it's a real number, so it can be any number. Okay, it says use calculus, now our differentiation, to find the coordinates of the local local minimum point of f. So this is a quadratic equation. Now it'll look something like that or like that. And we're looking for the local minimum point, the, the point where the graph stops going down and hasn't yet started going up again. And they give us a hint, they say differentiate. So with this question, the first thing I'm going to do is differentiate using the function notation. So we take each term separately and we use the power rule of differentiation, where we multiply the power by the number in front of the x. So 2 by 5 is 10. And then step 2 of the power rule is we take 1 away from the power. 2 take away 1 is 1. Now we do that for minus 20x. It's power by number in front. 1 by minus 20 is minus 20. But when we take 1 away from the power, 1 take away 1 is 0, which is going to create a bit of an issue, but we'll sort it out in a second. Now, any number when differentiated always turns into 0. Now, anything to the power of 1 is the same thing as, and to the power of 0 is the same thing as 1. So that issue is going to be resolved by just multiplying minus 20 by 1, because x to the power of 0 is 1. That leaves us at minus 20, and the 0 just drops off. So our differentiated function, or our derivative, is equal to 10x minus 20. Now, at the local minimum, okay, the slope, okay, or it's the same thing as f prime x, is equal to 0. So if f of x is equal to 0, I can swap it out. And then I get 10x minus 20 is equal to 0. So I can solve this by getting rid of the 20 here by adding 20 to it. If I do it to one side, I have to do it to both, and I end up with 20 is equal to 10x. To get rid of that 10, I'm going to divide it by itself, 10. Do it to one side, I've got to do it to both. I end up with x is equal to 2. Now, I have my x value, so there's an x and a y part of the coordinate. I have the x, but I'm looking for the y. Now, another way of expressing y is f of x. So I'm looking for what f of x is. Now, the only place I'm given f of x is in the original function. So all I have to do here is swap out x for 2 the whole way across. Now, that's a calculator job. Okay, so if I put that through the calculator or go to the answer here, I should be able to take over here. So I've swapped out the 2 for the x variable all the way through. I got a value of minus 18. So my minimum point is 2 on the x, minus 18 on the y. Okay. Or you could say 2 on the x, minus 18 on the f of x axis. So with function notation, the big thing to remember is f of x means y. So if they say the f of x axis or whatever, it just means the y axis, and then that will hopefully get you through. So with this question, and this is a kind of bog standard methodology to find the max or min. Step 1 is differentiate. Step 2 is whatever your derivative is or your answer to differentiation is, put it equal to 0. Then solve it, okay? And once you've gotten your value of x, put it back into the original equation you were given, and you'll find y. And that's it, 4-step method. So that's part B. Now part C says the graph of the linear function g of x is shown below. And we see it here now, it crosses the y-axis at 1, okay? And it's going up, now it's going up 2 units here for every 3 it's going across. So the rise is 2, the run is 3. Now slope is defined as rise over run, which would in this case would be 2 over 3. So the slope of that function is 2 over 3. Now the c value, which is the y-intercept, is 1. So, and I even reading the question, I probably should. If we can satisfy this equation here, that's one way of describing a linear model. The m there is 2 over 3 times x plus 1. So that's the linear model. Now, do we need that is the question. It says use the graph to find the rate of change of g of x, that is, find g prime x. Give your answer in the form of a over b, where a and b are elements of n. So give it as a fraction, okay, and a and b are natural numbers, so positive whole numbers. So 1, 2, 3, 4, whatever. So we did that already. Okay, the rise over run, which is all g prime x is the slope. So g of x is the function, which describes how the output changes based on the input. But g prime x is basically the derivative, which is a really simple way of describing the change at every point on this particular graph. Now, in this graph, it's linear, and in linear models, the slope doesn't change, which is why the rise over run will work. Differentiation or calculus really comes into its own with non-linear models and gives us a way of being able to understand the change happening within those systems, which is really powerful part of science and engineering. So that's the answer there, and that should be the end, I think. Yeah, that's the end of question 5. So as always, if you want a copy of the notes I'm working off, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists, and see you on question 6.